Morning everyone. Myself Kirti and I'm from Mechanical Regular. Today my topic is about switch fuse unit and miniature circuit breaker. Switch fuse unit. In basic electrical engineering, a switch fuse unit is a compact combined device that functions as both as a switch and a fuse used for isolating and protecting electrical circuits from overcurrents, typically found in low and medium voltage applications. Its functions are: the SFU allows you to disconnect or isolate a circuit for maintenance or safety purpose. The fuse acts as a safety device protecting the circuit from damage caused by overcurrents by melting and breaking the circuit if the current exceeds a safe limit. Types of SFU. First one, switch fuse unit. Second one, fuse switch unit. Third one, switch disconnector fuse unit. And the working principle of SFU is: in normal operation, when the circuit is in its normal operating state, the switch is closed, allowing current to flow through the fuse and to connected load. Overload or short circuit. If an overload or short circuit occurs, the current flowing through the fuse exceeds its rated capacity. Fuse operation. The fuse wire melts the breaking circuit and stopping the flow of electricity, thereby protecting connected equipment and wiring. Construction of SFU. SFU typically consists of a switch or for disconnecting the circuit, one or more fuses to protect against overcurrents, a common enclosure, often metal, to house the components. Here is a more detailed breakdown of its construction. Key components. A mechanism to manually connect or disconnect the circuit, typically with a steady side operating handle and a quick make breaker mechanism with a switch. A metal housing, often with a front accessible door, designed to protect an internal components and ensure safe operation, is called an enclosure. Applications and advantages of SFU. SFUs are commonly found in low voltage distribution boards and consumer units. Industrial applications where circuit isolation and overcurrent protection are necessary. Electrical plane panels and distribution systems. Advantages. Compact design. SFUs are designed to be compact and space saving, making them suitable for various applications. Cost effective. They are a cost effective solution for providing overcurrent protection and circuit isolation. Disadvantages of SFU. Fuse replacement. Replacing a blown fuse can be time consuming process, requiring the circuit to be disconnected and the fuse to be replaced. Not suitable for high fault currents. SFUs are not designed to handle very high fault currents, and in such cases circuit breakers are a better option. Important note. It, it is very widely used for low and medium voltage. The rating of switch fuse units are the range of 30, 1600 and 800 amperes. Switch fuse units are available as 3-pole and 4-pole units. Miniature circuit breaker. A miniature circuit breaker is an automatically operated electrical switch designed to protect low voltage circuits from damage caused by overloads or short circuits by automatically interrupting the flow of electricity. Here is a more detailed explanation. Its functions are: MCB acts as a safety device, preventing damage to electrical wiring, appliances, and equipment by automatically switching off the power supply when an overload or short circuit occurs. Its mechanism. MCBs typically use thermal or thermal magnetic mechanism to detect and respond to overcurrent conditions. Construction of MCB. Miniature circuit breaker is constructed with key components like bimetallic strip for overload protection, a solenoid for short circuit protection, arcs to extinguish arcs, and a switching mechanism to open the circuit. Here is a more detailed breakdown of MCB's construction. Bimetallic strip. The strip, made of two different metals with varying thermal expansion coefficients, detects overloads by heating and bending, triggering the tripping mechanism. Types of MCB. Here we can see there are types like type A, type B, type C, type D, and type K and type Z. Working principle of MCB. A miniature circuit breaker works by using current sensing, thermal overload protection, and magnetic triggering to quickly cut off the circuit if there is a short circuit or abnormally high current. This protects equipment wire from damage. How does an MCB works? The MCB senses current. If the current is too high or there is a short circuit, the MCB trips and cuts off the circuit. The MCB can be manually reset to restore power supply. Advantages and applications. Reusability. Unlike fuses which need replacement after tripping, MCB can be simply reset, making them more convenient, cost-effective in the long run. Quick response. MCBs react quickly to overloads and short circuits, minimizing the risk of damage to appliances and circuits. Applications. In residential farms, protecting household appliances, lighting circuits, and other electrical equipment. In commercial, protecting office equipment, lighting, and other electrical systems in commercial building. In industrial purpose, they protect industrial machinery, motors, generators, and other equipment. Disadvantages of MCB. MCB are generally more expensive than fuses, though their long lifespan can offset this initial cost. MCB can sometimes trip unnecessarily due to factors like temporary surges or loose connections leading to the inconvenience. MCB are slightly more complex in terms of installation and maintenance compared to the simple mechanism of a fuse. MCB have a limited lifespan, typically around 10 to 20 years, after which they need to be replaced. Thank you.